Okay, so yeah, the next lesson here in this stats unit is on something called z-scores. Okay, so and z-scores, we're going to be finding percentages. The deal with z-scores is that what we can do with z-scores, what we can do is we can actually find percentages that aren't on the standard deviation markers. All right, so from the last lesson, right, we went through the normal distribution and the 68, 95, 99.7 rule. These percentages here are kind of estimates or known, but they occur one standard deviation, two standard deviations, three standard deviations away. Right? Okay, so what z-scores allow us to do, it's actually, you know what, I'm going to scroll up a chart here. So this is a Z table. What it does is it actually allows us to find the percentages when they aren't on those standard deviation markers. So it's fairly specific. Yeah, so this is a table that we're going to use to find these percentages. Okay, and I'm going to go through how to look them up and all that kind of stuff. Of course, you'll be provided this table. You're not going to be asked to memorize it or anything like that. But anyways, the whole idea with z-scores is that in z-tables is that now we can find percentages when they aren't on the like one standard deviation or two standard deviations or three standard deviations away. All right. Now, that being said, what I'm going to do with this first example is I'm going to kind of do a little bit of review and introduce the z-tables through one question here where the actual number here, the 74 inches, is on one of these markers, right? And then what I'm going to do here is just go through when it's not. All right, so some examples of those. Let me just fix the formatting here. One second. Just want to move that up. All right. Yeah, let's make sure that one's. Yeah, perfect. All right, so anyways, scrolling back to here. Okay, so the first, I'm going to show you how to answer this question. All right, so we have the heights of males is normally distributed with an average height of 70 inches and a standard deviation of 4 inches. Okay, so I think this is fairly accurate. And what percentage of the males are? Okay, so the first one here, we're going to find out what percentage of males are shorter than 74 inches. Okay, so this here is the 74 inches is one standard deviation away from the mean. So I'm going to use this as kind of a review of using the 68, 95, 99.7 rule. And then what I'm going to do is I'm going to show you the other method with the Z-scores, looking it up on tables to find the same answer. All right, just as kind of like an introduction with the first with the first rule. All right. So shorter than 74 inches. Okay, so a little bit of review from last. So method one. We're going to apply the 68, 95, 99.7 rule. All right, so to do that, what I want to do is I want to just draw up a bell curve. And I'm just going to mark this stuff off. So in the middle here is the mean height, or the average height, which was 70. And then over here, I'm going to go one standard deviation away. So I'm going to add 4, right? So 74 on this side. I'm going to subtract 4 on this side. So that'll be 66. And we're going to go one more here. Okay, so let's go 78, add 4, subtract 4. And then last marker there is 3 standard deviations away, so that will be at 82, and subtracting that will be 58. Okay, so again, this is the mean, and then this is 1 standard deviation away is 4 inches. All right, so adding 4, subtracting 4, and then 2 standard deviations, and so on. Okay, so the percentages for these line up. So this is 34% on both sides. I'm just I cut and pasted this graph here on the left. I didn't really feel like reconstructing it at all, even though you probably can. But I just want to just kind of refer to it instead. All right, so that was 2.35%, and then the very small tails there at the end was 0.15%. All right. So to answer the question, it's asking what percentage, use the highlighter, what percentage is shorter than 74 inches. Okay, so 74 is right here. So Basically, we're talking about this percentage underneath the curve. Okay. So yeah, so we can I can add up these 4 sections, 1, 2, 3, 4, 5 sections, or another way is to realize that this is 50%, right? 50% of the population is less than the mean. So the answer in this case is going to be 50% plus the 34% on this side right here. So approximately it's going to be 84%. Okay, so this is the percentage of the population of males that are shorter than 74 inches. Okay, so this is using the stuff we did last lesson, right? The 68, 95, 99.7 rule. All right, so the answer there would be 84%. Okay, so again, I took 50%. So these 4 sections I added to 50% because that's the lower half of the mean, and then I added the 34%. Okay, so for a total of 84. All right. Now that's, so hopefully that's review. You guys were able to see that. But now what I'm going to do is I'm going to introduce using the Z tables. We should get the same answer, but this is just a different method. And then with this method, what we can actually do is we can answer questions like what percent of the population is shorter than 71 inches. Okay, so when it's not exactly, the number that we're looking for is not exactly a standard deviation away. All right, so that's kind of looking ahead. But anyways, let's answer this one here. So method 2. What I'm going to do here is I'm going to just use the Z tables. All right, so there's a formula, and this formula you don't really have to memorize. It's called the Z formula. Okay, so to get a Z value or Z formula, you'll see this X minus the mean divided by the standard deviation. Okay, so this formula here, what it does is it converts the normal population that we're working with here, right? The average of 70 and standard deviation of 4. And what it does, it kind of normalizes or standardizes this normal distribution so we can look it up into a Z table. Okay, so there's like an infinitely many number of normal distributions, but with this formula, basically what we're doing is we're standardizing it, which means that we're just converting it to a kind of a readable normal distribution, which is called the Z distribution. Okay, so hopefully that made sense. All right, so anyways, your first step here. Okay, so step 1 is what we want to do is we want to convert the measurement, which was 74 inches, into a Z value. All right, so using this formula, Z is going to equal, so my X is 74, because that's the measurement we're looking for. From there, I'm going to subtract the mean, which was 70, I believe. Yep, so the mean is 70, and we have a standard deviation of 4. All right, so 74 minus 70 divided by 4. All right, so if I work this out, 74 minus 70 is 4. 4 divided by 4 is 1. Okay, so the Z score for 74 is positive 1. And the way you interpret Z scores actually is that it kind of converts these normal distributions into, again, what they call a Z distribution. And the Z distribution or Z scores are standard deviations. Okay, so remember, if I look at going back to this rule here, you can see that when I drew this up, 74 here was actually 1 standard deviation in the positive direction away. That's why it's positive 1. Right? So you can imagine, right, just as an aside, that if I was to plug in, let's say 62 for X into here, so I go 62 minus 70 over 4, I should get a value, Z value of -2, because it's 2 standard deviations to the left in the negative direction. Right? So this would be a Z value of -3, -1. The mean itself would be 0, and positive 1, positive 2, positive 3 for my Z values, if I were to convert these ones. Okay, so for this question here, we're answering the 74, so that is 1 standard deviation away. That's why I get a Z value of 1. Okay. All right, so once we've done that, what we're going to do next step, so step 2, is we're going to look up the corresponding percentage. Corresponding percentage in the Z table. All right, so there are Z tables in the back of the textbook. All right, so there should be there as well. What I'm going to do is I download this PDF one, and I'm going to post this one as well if you want to use this one to refer to. All right, so yeah, so there's a couple Z tables that are accessible for you. Some of you would prefer this digital version. Others prefer the hard copy back of the book kind of thing. Whichever one, the numbers should all be the same. Okay, so what I'm going to do here is I want to look up. Let me scroll back here. I want to look up Z of 1, positive 1 in my tables. All right, so little description of these tables is there's basically 2 pages. Okay, so there's this page and this page. The first page here, what you'll notice is that the Z numbers here are all negative. Okay, because that represents the Z. They kind of drew a little normal distribution here. This corresponds to Z values that are negative, which are to the left of the mean. Okay, so all these over here, the Z values here would be negative, and conversely, all the Z values over here would be positive. Okay, so I want to look up positive 1. So if I scroll down to the second page, right, suppose I put the Z over here, these are all positive numbers. Okay, so the way this table works is that you would go to, you could look up Z values to basically 2 decimal places. All right, so in this case, I want to find the Z corresponding percentage for Z value of 1. But technically, you know what I'm going to do here? I'm just going to add in 1.00. Okay, so when we do these calculations here, yeah, what you want to do is you want to actually make the Z 2 decimal places, right? If you get a decimal that goes on for like ever, just round it to 2 decimal places. Okay, so maybe we'll make a note of that. 2 decimal places. Okay, so the reason we want to look up, or we want to calculate the Z value to 2 decimal places is because this chart goes to 2 decimal places. And when you first look at it, it might be a little bit weird in terms of what this all means. But basically what happens is that this left column down here, notice that it's to 1 decimal place. Right? So if I want to look up 1.00, I'm going to go to 1.0, and then I'm going to go across until I get to the other 0, right, which is actually the first one here. Okay, so if I want to look up 1.00, it would actually be this value right here. Okay, so I'm going to grab this highlighter. I'm just going to highlight it. Okay, so this is the percentage that we want to find. Okay, so this corresponds to 1.00. Right? If I wanted like 1.06, I would go down the 1.0 row all the way here to 6. All right, so this is 1.06. Okay, so these columns here just get you to the 2nd decimal place. All right, so hopefully that makes sense. So anyways, 1.00, we get a value here of 0.8413. All right, so let's 0.8413. All right, so the Z value that we looked up here, or Z, I'm going to call it Z percentage. I don't want to write the equal here, so Z, I'm going to write that as a percentage sign. All right, is equal to 0.8413. Okay, so this is a decimal. Now to convert it to a percentage, just going to multiply it by 100. And basically what that does is it just moves the decimal place over 2 places. So this is 84.13%. Okay, so it's saying that 84.13% is going to be less than 74. Okay, so which is the 84% is, these numbers are, I guess, an approximation to 1 decimal place. And here it gets to 2 decimal places. But so anyways, 84% we got when we looked it up. 84.13% is what we got when we looked it up in the Z tables. All right, so they are the same. The other thing I want to point out here as well, if I go to these Z tables, all of these Z tables represent the percentage from that score and then to the left. All right, so less than. It's always less than. These are all these percentages. All right, so so all of these here are, again, the shaded region, which is less than the Z score. All right, so you might be wondering, oh, what if I want to look up, or find out what percentage is taller than 74 inches? Well, it would be the other side. Okay, so what you would do here is you take 100%, which is the whole thing, and then minus the shaded region, and that should give you the other side. All right. All right, cool. So let's just, but I'm going to do an example of that as well. All right, so, but just make note and just remember that all of these percentages that are written in these tables are to the percentage to the left of that z-score, or in other words, less than that. All right, so let's go on to the next one here. So shorter than 74 inches. Okay, so 74 inches, actually, you know what? When I scroll it up here, if I wanted to know less than or shorter than 71 inches, notice that when I chopped this up into standard deviations, we actually didn't get 71. Okay, so we can't use the 68, 95, 99.7 rule to answer this one here, this question, because 74 is not on what I call a standard deviation marker. Okay, so the only way to answer this is to actually use your Z tables. All right, so first step here again, I'm going to convert it. So Z is equal to, again, X minus the mean divided by the standard deviation. So in this case, for our Z value, Z is equal to 71X minus the mean, which was 70, divided by the standard deviation, which is 4. Okay, so I'm using the same example, right, with a mean of 74, or sorry, mean of 70, standard deviation of 4. Okay, cool. All right, so this number here, this is going to equal 1 over 4, which as a decimal is 0.25. Okay, so it actually, 1 over 4 is 0.25. It naturally goes to 2 decimal places, which is good. All right. So then what I'm going to do here is, let's go to the Z table. I want to look up positive 0.25. Okay, so I'm going to go down this column. Here's 0.2, and then I got to go across to the 5. All right, so I lost my marker. 0.25 is this number right here. All right, so we get 0.5987. Okay, so real easy. Let's go back here. And so the Z percentage is equal to 0.5. I've already forgotten. 5914, 5987. Okay, 5987. All right, so this means that 59.87% is shorter than 71 inches. Okay. All right, so again, shorter than, again, the Z percentage is always to the left of that Z score. All right, so if that's the case, so 71 inches, if I want to figure out what the percentage that's taller than 71 inches, what I'm going to do here is I'm just going to show you kind of graphically what's happening, is that at 71 inches, we found in the previous question here that is 59.87%. All right, but what this question here is asking is how much is taller than 71 inches? So let me just take the highlighter here. Basically, what we want to do, this highlighter, is find this. You know what? I'm not too happy with that. Use a red marker. Is basically asking you what's this percentage over here. Okay, the taller side. Okay, so what we're going to do is just use the properties we know about the normal distribution. All right, so we know that underneath here, this represents like the whole area underneath the curve here is 100%. So if I know this side is 59.87, logically, what that means is that this side, the taller side, is going to be the 100%, right? The whole thing minus the left side, so 59.87%. Okay, so that's going to equal 40.13%. Okay, so 100 minus 59.87, all right, is 40.13. Okay, so that's just kind of like the other side. So yeah, so if 59.87% of the population is shorter, right, I got this number again from this here, right, shorter than 71 inches, then the other side, or the remaining population, which we're going to take 100% and minus that side, which will give us the other side. I know that doesn't sound too mathy, but you know what I mean. All right, so anyways, this red section in the 59.87% should add up to 100%. All right. Cool. All right, so let's scroll her down. All right, so let's do one. I think this is the last one. Yeah. Okay, so what percent of the population is between 5'7" and 6'1"? All right, so rather than looking at what percentage is shorter or taller, now we're looking at in between. All right, so we have two values here. And what the first thing you'll notice here is that these are in feet and inches. So what I want to do first is actually convert these. All right, so yeah, I kind of threw this in as an added twist, but anyways, we should all be able to convert these. All right, so 5'7" is the same as I just said it, 5 feet 7 inches. All right, so in 1 foot we have 12 inches. All right. So that means that to convert this to inches, I'm just going to take the 5, multiply it by 12, right? Because there's 12 inches in a foot. So that's 60 inches. And to that, I'm going to add another 7. Okay, so that is 67 inches. All right. Hopefully that makes sense. All right. So 5'7" is 60 inches plus 7 inches, so 67 inches. All right. Likewise, I'm going to do the same thing with this one, convert that one. So I'm just going to go 6 feet times 12, which is 72. And then to that, I'm going to add 1. So 73 inches. Okay, so this question here is asking what percentage of the population is between 67 and 73 inches. Okay, so as a strategy, basically what we're going to do here is we're going to find the percentage that is shorter than 73. All right, so we're going to find this percentage here, and then do the same with 67. All right, so these aren't the best sketches, but 67 would be over here somewhere. Right? And then if I want to figure out the percentage between, basically what I'm going to do is I'm just going to take this percentage and subtract this, right? So subtract. And as a result, as a result, I will find, once I subtract it, that's 67, this is 73. Whatever's left when I subtract the two percentages should be the percent in between. Right? So if I took this minus this, right, off that, actually, maybe it's visually, it's better if I do this. Right, let's say 67 is there. If I subtract that, then I'm going to have what's left over. All right, so hopefully that makes sense, right? So again, find the whole percentage here of less than 73, find the percentage that's less than 67, and subtract those two percentages, I will get what's in between, and that's what I want. All right, so let's do it. Okay, so first thing I'm going to do here, I'm going to do the z-score for, oops. It doesn't actually matter which one I do first, but let's just do the z-score for 73. Okay, so z equals 73. Again, the mean was 70 divided by 4. So that's 3 over 4, which is 0.75. All right, now the other thing I want you to realize is that, yeah, this z is the z number. This is not the percentage, okay? So some students get kind of thrown off and say, oh, that's 75%. That's not the case, right? This is actually 0.75 standard deviations away from the mean is 73. So we still got to look it up. Okay, so 0.75, where's that? 0.7, and then I'm going to go across to the 5. So that's this value right here. So that's, and I'm going to write it as a percentage right now. So that's 77.34%. All right, so I'm going to draw an arrow and just write 77.34%. All right, now I'm going to do the same thing. Actually, I'll call this Z1. The other Z score, all right, is that I want to look up is the 67. So I'm going to go 67 minus 70 divided by 4. Okay, so this one here is -3. Okay, so negatives count, right? So 67 minus 70 is -3. So that's -3 over 4. So I'm going to look up -0.75 in my Z table. All right, so yeah, so negative Z values are on actually the first page here. Okay, so notice that these values here are negative. These values here are positive. All right, so I want -0.75. Just see if I can scroll it. No, okay, so I got to zoom out a little. go to 100. All right, so okay, so here's negative 0.7, and I got to go across to the 5. So that's like right there, I think. Just confirm that. Yeah, negative 0.7, and then down the 5 column. Yep. So 22.66%. All right, so 22.66%. All right, so this is the percentage of the population that's lower than 67 inches. So now what I want to do is find the section in between here. So I'm going to subtract these two. All right, so let's just let's pull out a calculator here. All right, so again, I'm going to go 77.34 minus 22.66. All right, so what's left over? 54.68%. Okay, so that would be our answer. All right, so yeah, so Z tables. Yeah, so Z tables are what we need to use if, again, we're trying to find values or percentages where the numbers themselves are not like whole standard deviations away. All right, so yeah, so and again, we can do shorter than was the percentage that we just looked up in the tables. Taller than will be 100% minus the percentage that we look up in the tables. And then in between, you basically look up both percentages and subtract them. Cool. All right, guys, so hopefully that makes sense. Yeah, this is a little bit, it could be a little bit of a tricky concept. Totally get it. So if you got to watch this video again or pause, it's totally normal. All right, so yeah, so just watch this again if you have to. You might not get it the first time, which is totally cool. All right, guys, cool. So that's that.